Assalamualaikum. My name is Muhammad Fibri Ashraf, CE210093. We are from Group 2, Section 4 for subject BEE 32402, Numerical Method. We are going to do a short presentation about our project. So, group member, our group member consists of four, include me, which is Muhammad Danish Aiman, and me, Afif, Muhammad Zufar, and Ahmad Farhan. So, for introduction, anti-differentiation, also as in the inverse process of differentiation, it is used to find the original function that was differentiated to produce a given derivative. By using integration, the area or volume under the graph or bounded by several curves can be calculated. This is known as a definite integration. The velocity and the distance of an object can be calculated by integrating its acceleration over time. Integration can also be used to approximate the definite integral. This is done by using techniques such as trapezoidal rule and Simpson rule. So there are several numerical methods that can be used to approximate the definite integral, including the trapezoidal rule, which approximate the area under the curve as a series of trapezoid. Simpson 1/3 rule, which approximate the area under the curve as a series paraboloid. And lastly, for Simpson 3/8 rule, which is a more accurate version of Simpson 1/3 rule. So I will pass to our next presenter. Thank you.
Okay, now I will continue to next topic, methodology. Our group use two methods, which is trapezoidal rule and Simpson's 1/3 rule. Okay, trapezoidal rule will divide the whole area into smaller trapezoids rather than utilizing rectangles to calculate the area under the curve. This integration determines the area by approximating the region beneath a function's graph as a trapezoid. So we have a trapezoidal formula. Delta x divided 2 times by fx naught plus 2 summation fx iteration 1 until how many interval we have and plus fxn. Okay, next we have Simpson 1/3 rule. Simpson's 1/3 rule use parabolas to approximate each part of the curve. This proved to be very efficient since it is more accurate than the other numerical method we have seen. We divide the array into n equal segments of width delta x. Okay, to find area with integration, we must integrate fx respect to the x and have upper boundaries and lower boundaries. So we have delta x, which is our step size, our h, divided by 3 and times y naught plus 4 times y iteration even plus 4 times y iteration odd plus 2 times y iteration even and plus yn. So we will use Matlab software that we must build according to information given and run it to get the result. After we run the program, we must compare our manual calculation and the Matlab answer, and we must get the equal answer from that. This is our question we get from general random general internet. So we will use the equation, this equation, and we use 10 interval. Okay, we will use this graph for our reference project.
Hi, Assalamualaikum. My name is Muhammad Zafar Aziz bin Muhammad Saimi. My market number is CE2100288. So I'm going to compare between the simulation and the manual calculation. So this is our manual calculation for the trapezoidal. The final answer is 0.3332. So the second is the Simpson rule, but we use the 1/3 rule. So our answer is similar to the previous one, which is the trapezoidal. The answer is about 0.332. So about the similar with the previous one. So without further ado, I'm going to explain about the simulation on the Matlab. So in this coding, first of all, we have to put our function firstly. So our function is based on our questions. So our limits of integration value, which is the a is 0, meanwhile the b is 2. So the number of interval is 10. So you can get the interval size by use this formula, h equal to b minus a over n. So after that, we just use the exact formula for the Simpson, or for the trapezoidal. So the only difference is the last equation, which is the for trapezoidal we use h for 2. Meanwhile, the trapezoidal we use h over 3. So I'm going to run for the trapezoidal one. So our final answer for the trapezoidal is also similar to the manual calculation, which is 0.332. So there is no actual error to compare with the manipulation. So the next one is the Simpson 1/3 rule. So the outcome shows that our final value is 0.332. So this as a conclusion, we get the similar value with the manual calculation. So that's all. Thank you. I'm going to pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farhan bin Muhammad. So I'm going to explain for the analysis. Okay, from the all data above, we can conclude that manual calculation from this method is same as Matlab. Program that we produce the same answer, which is 0.3332. This value represents the total value under the graph based on the engineering problem. That's in the question. For the manual calculation, the formula we obtain from the module and some other reference on the internet that give this same formula to solve this mathematical problem. Meanwhile, for Matlab, we just key in all the formula to this method and verify the result. So in the conclusion, numerical integration can be accomplished by using variety technique such as the trapezoidal extension we are using, and it also has advantage and disadvantage. Popular technique include while the trapezoid approach is more exact than the rectangle method, it is still comparatively simple to use. Simpson's rules is more accurate than the latter but more difficult to apply. The intricacy of the function we are attempting to integrate the precision we require will determine how it works. So I think it's all for my conclusion. Thank you.